So here I'm going to show a little demo for the scheduler slash toy operating system that I made for the Atmega 168 microcontroller. So right now you're seeing a terminal window that I'm going to use to run a Python script that will communicate with the chip over serial. So the chip right now is running the scheduler code but doesn't have any tasks loaded. To see this, I can run the list command, which shows that there are 4 task slots that can have tasks loaded into them, but right now none of them are being used. The little plot at the bottom shows that there's free pages that the task data is going to be loaded into. So to actually load a task, I run the load command, and here I'm loading a task that I'm going to name LED, and the path at the end is the path to the object file that will be relocated into the task section of memory. So the number there is it's being loaded into an address in the flash memory, and if I rerun the list command, we can see that the task is there. It's red because it's not yet running, and at the bottom you can see that task 0 is using 1 page of memory. So now if I enable the task, I can either enable it by the task number or by name. I can now see that the task is green, so it's up and running. Now what the LED task does is that when I send a exclamation point, it will toggle an LED. So to actually run it, I can start a terminal, so now I'm just, whatever I type here is going to get sent over serial to the board. And if I type exclamation point, we can see that the board goes on, and another exclamation point, and it goes off. So now I'm going to load some more tasks on there. So this is the path to an echo task that I wrote, and I will load 3 separate instances of it. So now if I list them, the LED task is automatically disabled as just part of the bookkeeping for loading new tasks. And you can see that these echo tasks each take 4 pages instead of the LED tasks taking 1. So now I can enable all of these tasks. You can see the 3 echo tasks are now running. So now when I run the terminal, I can type hello, and you can see how the first task was able to read the text out of the buffer. Once it finished, it released a lock that the second task got, then also did the echo, released the lock, third task got it, printed out its response, and then the first task got the lock again, and the other 2 tasks are currently waiting. Now, as a slightly more complicated echo, if I type something a little longer, you can see that the tasks weren't able to echo the whole thing on one go because their buffer is only 10 characters or so they end up having to go around twice. So now I can disable a task. So I'm going to disable the last task. See that only echo 1 or 2 are still running. So now if I run the terminal, we can see only those tasks are present. And one last thing I can do is I can actually delete the second task. And now only task 1 should be running. And there we are. So that's a demo of the very basic functionality. The idea that these tasks are sort of equivalent of the processes running on a normal computer. So they could be started and stopped and swapped out. And while that's not particularly practical, it demonstrates what could be done even on such a simple microcontroller.